Hi everyone, my name is Christine Hirst Bernhardt and I am an astronomy education enthusiast. I've spent my entire career infusing earth and space sciences into my content. I created an astronomy course in Pathway at a high school. I'm now teaching middle school science. I'm on the NSTA Aerospace Advisory Board. I'm a NASA JPL Solar System Ambassador. I got to fly on NASA's SOFIA mission, which you can see in the bottom right-hand corner, which has an onboard infrared telescope. And I was selected to travel to Chile as an astronomy and Chile education ambassador. I'm also a boy mom, a newlywed. I love adventure and traveling internationally, which I cannot wait to do again. And I am now a PhD student. I entered a PhD program at UCSB with the intention of studying the infusion of Earth and space sciences into all courses that are now NGSS. But because I've been a career educator, one of the things that I'm finding that's really striking a bone with me is the disparity in education research and the intersections for the classroom. I don't feel like education research has ever really impacted me. Maybe it's not impacted you either. And I really want to bridge that gap. It's really unfortunate that education researchers have such little classroom experience. So I'm hoping to infuse a bit of that into earth and space sciences as I'm studying my PhD. So I'm going to be showing you some ways that we can integrate astronomy education and astronomy components into distance education. If you're like me and if you're anywhere in the state of California, you are probably teaching remotely. I found that astronomy education is perfectly suited for remote classes. And you may not think that this really applies to you, but if you are a science teacher in the state of California, you now have to teach this. And I'm going to share that with you in just a second. So I'm going to share with you today some lessons that I've created on moon phases, starlight and stellar evolution, space missions, some observing projects, and some citizen science projects, as well as a few others that I'm going to share with you that are all posted on a website. So maybe you're thinking, why the heck would I care about astronomy education? I teach biology or chemistry or physics. But unless you've been living under a rock for the last 5 years, you know that the implementation of NGSS and the incorporation of earth and space sciences is inevitable. And had COVID not happened, in 2020, all districts in the state would be required to be in the implementation stages. Most districts have gone with a stair-step model where they're starting with Living Earth and picking a year, and all 9th graders are taking that. Then those 9th graders go into chemistry in the Earth system, and those 10th graders go into physics of the universe. If your district was early adopting, you may already be on that step 3 of physics in the universe. You may only be on step 1, but I find it hard to believe there are any districts in the state that are not in any implementation stages, because we are supposed to be in an assessment year. So I want to give you some examples of some theoretical framework overlap of these big contextual shifts and how they relate to every content area. And if you would just like to skip ahead and see the content, you are more than welcome to skip ahead in this video. But I want to talk real briefly about how this affects every one of these standards. I recently created all of the content sequencing and highlighted all of the areas of overlap for LAUSD. If you have any questions about what LAUSD is doing or about any of those textbooks, I had to read all 9 of those adopted textbooks for every single course. I then curated a bunch of activities and virtual field trips that LAUSD, in conjunction with NASA, is going to be building out over the next 5 years. Every district will then have access to those, but I am the author of those. So if you're an LAUSD, I am the expert on your text. If you are choosing text to adopt, I have documentation that I created about the ranking of each of those texts. So feel free to shoot me an email. So climate change, you can see all of the subtopics in each of those courses. Earth's history and Earth's interior, you can see all of those documented in each of those courses and all of that carryover. And these are the big areas of overlap in each of these. So climate change has carryover into each. Earth history and Earth's interior has carryover into each. Atomic spectra, with the exception of living Earth, which has the most minimal change, has carryover into each content area. Natural resources and Earth's surface has carryover into each content area. Also, plate tectonics has carryover into each area. So I have this document embedded on my website, which is for this conference session, and you can feel free to take a look at that. And this is a conceptual framework, again, that I created as I was pouring through the framework of California NGSS and looking specifically at our DCIs and performance expectations in Earth and space, and how these areas of overlap impacted and crossed over into the adopted text of LA Unified. Okay, so I now want to take you to this website that I created, and you can find this on the CASE website. So the title, of course, of this is Astronomy is Out of This World. And as kids, we're all naturally curious about astronomy. We look up at the moon, we're fascinated by the stars, by space travel, by aliens, and somewhere along the line that gets standardized out. When I was a kid, I started writing essays on Jupiter and about space, and my earliest memory is of Krista McAuliffe and the Challenger disaster and being funneled home from kindergarten when that happened. And I never knew that space was an option. I actually never knew science was an option. I grew up with a huge science phobia. And my mission in astronomy education is to really change that paradigm for students like me that didn't know this was something they could study. And there's so many aspects of astronomy that you don't just have to have a PhD to be able to do. And the remote environment is perfect for the integration of astronomy education. So I'm going to show you the ways that you can incorporate astronomy and space sciences into remote environments, into every class. This is also if you happen to be teaching astronomy. I'm giving you the tools to teach an entire course without having to recreate anything. And if you're like me, this is creating so much more work for you. So please let me help you out and take the burden off of you and take the stuff that I have created. Oh, apparently Norton is telling me I need an update there. All right. So here is that document. So what I'm going to do now is I'm going to walk you through some of the areas that I have on my website. But what I'm going to ask you to do is, if there's areas that you are particularly interested in, you can just press pause, and on the website, click on the links and go through the items. This is years worth of material that I've created, and there is not enough time. We would be sitting here for many, many hours. And if you're like me, you are all zoomed out at this point. And we would be here for a very long time if I walked you through everything. So instead, I'm going to walk you through the highlights, and I'm going to allow you the time and the respect as a professional to go through each item on your own. So these are the items that I have for you. So here, the major topic is the moon. And here I've highlighted the subtopics, which is I already identified. This is an area that has overlap into every single content area. And when I was teaching face-to-face, which seems like a decade ago at this point, things like moon phases, I thought always required a manipulatable, and I always had models. But I wanted to, when I come back to this in a second, I'll show you some ways that I've created things in Google Docs, in Google Drawings, in Google Slides. So all of these things, if you use Google Classroom, you can take these and embed them immediately in every single one of my lessons. So one of the topics we're going to talk about is the moon. The next is starlight, and you can see the subtopics there, which has overlap into every area except for living Earth. The next are some general night sky observations, which get students out and actually doing observational science, actually collecting data. And for many lessons, I have multiple grade levels. For me, this was when I taught a regular class versus an astronomy class, and the regular class would be equivalent to grades 8 through 10, and the honors class would have been equivalent to grades 11 to 12, which would be right there. Next, I'm going to walk you through something that I got from an entity called Orion's Quest. And Orion's Quest is pretty amazing. It allows students to collect data using citizen science and real authentic science on board the space station. I'm going to walk you through all of those lessons that I have through a program called Spiders in Space. There are plenty on Orion's Quest, but they were not exactly integratable into a remote environment. I spent probably 100 hours and adapted everything there for the remote environment. Please take it and use it. So I have a bunch of material there for that. Next, I have projects, and I have a bunch of different projects to share with you. Again, all of which are usable in the remote environment. And then I have some general astronomy labs. So just to go over again, some websites that are useful in the remote environment that I will be touching on are Infiniscope, Orion's Quest, EarthCam, Stellarium, and Tomatosphere. If you've not already checked these out, I highly suggest you push pause on this video and you check these out. These are all free. These are all highly integrative and interactive, and students love these. And these are all perfect for the remote environment. So if you haven't already created an account, again, you can find the slideshow at the top of the website. All of these are links to these. So go ahead and push pause and do that. All right, so now that you're back, I want to walk you through a couple of highlights in each section. So you can see from the moon phases topic, I have this separated into two categories. I have cratering because there are cratering subtopics and carryover into every one of the content areas. If you are teaching living Earth, this comes into play when you're talking about the formation of Earth's atmosphere in early Earth and also surface processes. If you are teaching physics in the universe in terms of collisions, momentum, and forces, you will be talking about cratering. Moon phases comes into play when we're talking about interactions. And I want to highlight a couple of things for you. So for cratering, I have quite a few things here, two of which include background information. And these link you to other slide or other web pages that I've created. So for example, here is impact crater degradation and formation. So again, this is another one of my websites. I've created all of this. This is a lot of background material that students can go to. Comparing craters and analysis. Again, this is another page that I've created where students compare craters. This is perfect for both living Earth and for physics in the universe. Impact sites on Earth. Here I have a simulated impact Earth project where students also investigate near-Earth asteroid data, real data from the Near-Earth Asteroid Program at JPL. And for a lot of my lessons, you're going to see where it says master, because this would be something that then you would share with students. So a NEO or a near-Earth object, and they're actually going to the JPL database. And at the conclusion of this, they are creating an impact. This is a pretty cool simulation from Purdue that allows them to create an impact and to change the parameters in terms of the target, the projectile, and to make some observations there. Then here I have a really awesome, I've spent many, many years perfecting this lab of creating craters. When you go back to non-virtual teaching, please take this. I have it at 2 different levels. Again, I have done this lab for 14 years. This is the final amazing version. I have done this with multiple classes many, many times. Then for moon phases. So again, I have an introduction. And here is a reading assignment with some annotations that I have students do. You could either print this, have them do it in Kami, however it is. So I have them do this as homework, and I have some questions afterwards. Here, these next 2 things are really conducive for the Google Classroom environment. So for this is really an inquiry base, and this goes perfect with the Infiniscope moon phases, which is really based on a gaming and design model. So here that you would embed this into Google Classroom, and students would go through the slides. They each have their own slides, and they would then manipulate each of these to model how they think each moon phase occurs. And they just go through, they answer the questions after they've placed their models. Let me move that back so you don't get one that's out of place. They work through their investigation. This is again aligned with Infiniscope, answering the questions. What role does the sun play? And here, what they're doing is, ideally we would be doing this in class and students would be drawing this. But here, they're manipulating every component. They're moving all of these half moons. They're moving the arrows to indicate the sunlight. They're moving the positions of here their new moons. So this right here simulates, this is the correct model. So we have the here would be what we would see would be no moon, but here's what's actually happening is that the side that's facing the sun is illuminated. And the whole goal here is that they see that relationship that all moons are technically half moons. And I love throwing in the Pink Floyd puns there. Those are always fun and gives them a little classic rock education. So then once again, they're manipulating their original model. Another here that I really like is a moon phases Google drawing. And again, this is a student manipulative that they do at the conclusion of the Infiniscope activity. And you don't have to use it with that. There's so many moon phases activities. So here again, they are manipulating each of these models so they can just copy and paste the sun, copy and paste the earth, copy and paste the moon. And they're modeling the orientation or the geometry of each of those phases. So I have quite a few other things here. Moon phases simulation. This uses a couple different simulation sites. I have a moon phases quiz. And this would be something that if we were in class, they would draw directly on. You would have to take this if this were in a remote environment. And this is obviously, this would be for one student, and they can add things because this is a Google drawing. And this would be higher level. And this is with phases and eclipses. And here would be the link for Infiniscope. Next is starlight. So stars are such a huge topic, especially in physics of the universe. In physics of the universe, you're looking at stellar spectra as that applies to atomic spectra, what the implications of stellar spectra are, how we classify galaxies, how we know what we know about the universe. So I have a few different things here for classifying stars where students use an inquiry-based method based on some images of stars to provide their own classification scheme. And here are those images. If in class, I would have those printed, but it actually saves a whole lot of paper to not do that. And then here is the investigation. So they have to come up with their own classification scheme and be able to investigate those relationships. If you're teaching physics of the universe, depending on the textbook you use, you may go into the HR diagram. These next two lessons allow an integrative exploration of that. Star in a Box is put out by the Las Cumbres University, or Observatory, I'm sorry. And this is a really cool interactive. And I created a pretty neat lesson that goes with that. Stellar cluster ranking and classification, depending on the depth that you're going with, and galaxy classification, again, depending on your textbook. And if you're in LA Unified, feel free to shoot me an email. I can tell you exactly which textbooks are going to hit on those things. Then if you are teaching either chemistry in the Earth system or physics in the universe, you are going to be talking about electromagnetic spectrum. And I have two different, I have a quick project here where students are identifying daily uses of EM spectra, gamma rays in everyday life, and then understanding EM spectra. Then I have some mission projects here where students have to identify what their observing target would be and what the appropriate spectra would be for that. So we review then again what the atmospheric windows are, what sort of astronomies are done using each of those spectra. They create a presentation of this. So cloud-based presentation, they have to choose which telescope they're going with. These are, multi-wavelength observatories, introducing the wavelength they chose and what their observing target would be. I also included here a sunspot tracking assignment, which I hit again, and I cover this again in the observing projects section. So next is night sky observations. So I gave a few options here. This first one is using a software which is web-based. I highly suggest the free web-based platform, not the apps. Those look a little different, and my assignment aligns with the web-based version. So here again, this is called Observing with Stellarium, and I gave the link for that right there. And this is a pretty cool software, and this requires students to capture screenshots of what they're observing. This introduces coordinate systems. This introduces night sky observation and celestial sphere, really in a way that in the classroom, I've struggled to introduce for years. Students have a hard time conceptualizing this idea of coordinates on the celestial sphere. So this includes things like azimuth, altitude, where to find things given those two pieces of information, zenith and the horizon view. So they would have to then identify those. I also then include hand measurements. So students have to be able to recognize if something is 15 degrees apart in the sky, how would that look? So here is a little screenshot of Stellarium. You can then just change this for whatever your location is. And they include some screenshots of the objects that they see. And I have done this with multiple grade levels, including college. Students seem to have learned so much more about coordinate systems that way. If you are not teaching astronomy, this section may not be of use to you. Feel free to skip forward to the next one. So next I have a night sky naked eye observing project. This one works really well with any star viewing app such as Skyview, Google Sky, even Stellarium. Then I have two different moon observations, which require students to make multiple observations over a 2-week period. Again, you'd have to change the dates. Ideally, this should be first quarter moon to last quarter moon. Otherwise, they're observing during the daytime. And then I included the sunspot tracking. And the sunspot tracking could really be used in every class because students are investigating the role of the sun in terms of climate and the different various climate models. So they should know about energy output from the sun. So this is utilizing the Solar Dynamics Observatory and the SOHO Observatory, where students are observing real-time imagery of the sun in order to track changes in solar activity. So they have a couple articles to choose from. They have to choose the wavelength of their sun. They have to include screenshots of that. They have to circle regions of activity. And they have to make some observations and record data by assigning a group ID, counting the number of spots, and measuring the size of those spots, and then tracking changes over the course of 3 days. So this would be a larger project, but again, perfect for the remote environment. I've done this exact same thing in person because this requires real-time data for them to do. So next, I'm going to talk about a project that I did through Orion's Quest. And Orion's Quest is a pretty amazing and free resource that I wish I had learned about sooner. I learned about this through Space Station Explorers. And this website allows you to utilize space-based experiments through a variety of missions and bring these directly into your classroom and run analog experiments and allow students to replicate and make observations about real science that's done on the space station and report that back to the researchers. I'm doing this right now with 7th graders. So just to give you an idea, this is what my students are doing right now. We are doing something called spiders in space, where students are measuring the spider, they're measuring the growth, they are measuring the hub location and making qualitative observations. They are measuring the spider orientation and making qualitative observations. And they are comparing the web between the flight spider and the ground spider. So in all of these cases, there is a spider that is on the space station and a spider that is on the ground. You could utilize this for any science class because this is real science. This is every single SEP that you will hit, carrying out investigations, analyzing and interpreting data, using computational thinking, engaging in argument from evidence, constructing explanations, obtaining and evaluating, communicating information. Every single SEP is hit by this investigation. So again, mine is spiders in space. But if you were to do any of the Orion's Quest explorations, all of them have the same sort of background as far as the International Space Station and NASA. So again, I'm doing this with a middle school science projects class. So I had the ability to design a 4 to 6 week project for this. You could easily take components and do this in a day. You could do this as a week. There's many different varieties. So this investigation consisted of background information, pre-investigation activities, including metric practice, which every kid needs, and some student investigations and conclusions. So for the entire activity, what I did is I utilized breakout rooms for students to collaborate and share ideas. I used Google Jamboards, which I share with you in a second, and collaborative slides for students to present their findings and to share ideas. I require screen sharing of all of my students when they are in a breakout room. I assign multiple, different people a day, different parameters for that screen sharing and breakout rooms. And this allows me to see any mistakes, any errors in thought, any revision that needs to be done, such as the interactive graph, which I'll share with you in a second. So all students had to do their own work and they changed groups every day. Because if you've used breakout rooms, you know that manually putting them in based on predetermined groups is a pain in the butt. So I change them every day. So here is some NASA background. So again, a lot of these things are available on Orion's Quest, but they're PDFs, which means if you are in a Google Learning, say you're doing Schoology, Google Classroom, Canvas, whatever, students can't do anything really with the PDF. Maybe you have Kami. I can't even get Kami to work. So for example, students learn about NASA's background. They learn about NASA facilities. And one of the tasks that Orion has them do, sorry, that isn't ridiculously small. One of the tasks that Orion's Quest asks students to do is be able to identify where these places are in the US. So I took this map and I made it a Google slide. So and I added in text boxes, don't worry, for students to put these in and be able to identify them. And I made the instructions on the second page, because if you use Google Classroom, you know that the one little trick for grading, instead of expanding every student's work, is if you click on one, you can see it. So by making the slide something that is that's the first thing instead of the instructions, you don't have to expand them all. You can see so easily if they did it, because I'm all about working smarter, not harder. So, and here's a key here. Then for some ISS background, I created a Jamboard in which students had to rank the importance of things to bring to space. I'm a huge fan of Jamboards, and students love these too. And it's just a really great way to get them conceptualizing things and talking and revising their ideas. This idea of not finalizing their thoughts, but constantly building upon. I have 2 assignments on ISS in background information, utilizing NASA's sites, where they have to look at some comparative differences between doing things in space versus not. And they have to find some things that interest them, and they all choose going to the bathroom in space or sleeping. Then I have a collaborative slideshow where they did have a group that they were working with. I put all instructions in the slides, and it's their job to go through and delete the instructional text. This was really cool, and students learned a ton about the microgravity environment. I then had students evaluate. I had them present to each other in breakout rooms, and I had them evaluate each other. It's amazing how many students missed this box that says highlight the box to indicate the score, but half of them did. And I had a group grading and self-reflection. So then I had some background material for spiders in space. I took this from Orion's Quest and I just created an assignment for it. I don't particularly like spiders. So as you can see here, do you know that they're the most abundant predators on Earth? I learned that and was grossed out too. But this one provided a really cool quantitative and qualitative study. So then they had specific, this is again from Orion's Quest, the spiders in space background. And then from both of those 2 things, I created a Jamboard. And this is a 3-page Jamboard. And these integrate perfectly into Google Classroom. So they had, I use these a lot for definitions. They had to drag the sticky for the definition. They had to add 5 stickies that they learned from the reading. And once they read through the background information, adding 4 stickies to describe what scientists were actually doing by sending spiders to space. Then I created 2 additional assignments because some of the experiments require students to measure components and identify components of the spider and of the web. So I took a diagram of the spider and I created an assignment where students had to draw it either digitally or hand drawn. Pretty much all of them hand drew it. And they had to identify and define each of these yucky spider parts. And another where they had to identify components of the web. And the pictures are on the back of it. And I had them do this part in breakout rooms. And one of the big takeaways there is in the web diagram that there is a component here, the U-turn, where the spider changed directions. And that's one of the things they have to count in one of the activities. I realized as soon as I started that students had no idea how to measure at all. And to preface this, students did need a measurement device. I reminded them for weeks. I sent an email home to parents reminding them. Even their student planners that the school gave them had a measuring device on it, and that would have worked too. They literally measure the screen. So I created this metric practice assignment because they needed the practice. I have a predictions sheet, 2 different versions, and a slide deck on developing a research question. And in that, they make predictions for each of those activities. So then for each of the activities, activity 1 was the most quantitative. And for this, and this one was the most in depth. So here was where they actually had to measure, and it was the only one they had to measure. And not all students had a metric ruler. So here you can see this is like an example of the key, so I can see how big they are. So I created a spreadsheet with tabs at the bottom. And here they had to put in each of their spider sizes, the space spider and the ground spider. And I just coded this to already create a graph. But some students had theirs in inches. So I ran a script through it. And again, you can just take this and make a copy where it converted it to millimeters. And then the last tab is their graph. So it creates that for them. Then for each of the activities, I have some culminating slides where they have to insert screenshots. So in this case, it was your largest flight and largest ground. They have to draw some conclusions and make some summaries, and then a screenshot of their graph. I then made another slide. This took a ridiculous amount of time, where they had to click and drag dots to represent both the space spider and the ground spider and to actually put it on the graph. And so they had to learn how to read a graph in the process of doing this. And I gave an example slide. And again, putting their assignment slide as slide number 1 makes it far easier to grade. But it's amazing how many students didn't measure correctly and their graphs went down. And I said, wow, you have a miraculously shrinking spider, which they didn't. So they had to fix that. So activities 2 through 4, far more simple. So the culminating project is they complete the assignment, the task, the descriptions in Orion's Quest. They're inserting screenshots. This one was the hub location, describing the differences, inserting another screenshot, describing the differences in the second set of images, so they had to insert 2, and then describing how it changed. So multifaceted component there. Same thing for orientation and the web comparison. And then the conclusions activity. This is really awesome because this hits so many facets of science. This is so perfect for the remote environment. And students learn so many skills throughout the practice of embodying what a scientist does. They're doing real science. This gets reported back to the real scientists. I will remind you that because this gets reported back to them, you don't actually see as the teacher what students are putting in on Orion's Quest, but don't tell them that. I lie to them and I let them know that I can see everything they're doing and they better write full paragraphs. And I hope that they do. The next section that I have is space projects. And I'm not going to walk you through all of them, but 2 of them are readily available for you online, and that is Sally Ride Earth Cam. And I adapted I mean, that can be an assignment that either takes a day or it can take a couple weeks. And I found that to really make use of that, to really allow the students to analyze these space images, really took a bit more time for them to make meaning out of it. And it was really powerful to have students look at these images of areas that are being flooded by rising seawater, or they learned about desertification. They found areas that they had never even heard of before that were hugely impacted by mining activities, all from this. So there's a huge environmental component and a social justice component of this. So I created an assignment called image analysis. And this includes my username and password, so obviously you would change that. And here is an example of one of those images with the information. And again, work smarter, not harder, take mine, and I have them compare this to Google Earth, so they can actually, instead of just being like, oh, that's a cool photo, I want them to learn about and investigate what the environmental issues or factors are that are present in their image. And I challenge them to go deeper and to qualify their assumptions and to investigate. Then I have a rubric for that, and they have to present, and these are some Google Slides. Tomatosphere, if you are doing that, that would be super cool to do remotely. I have a project overview. I created a data collection and an experimental design component. That's also a free resource where students plant seeds. It's a double-blind study where they plant seeds, half of which have been to the space station, half haven't, and students don't know which are which. Satellites and Social Justice is a multi-day assignment that I created, which allows students to investigate the role of satellites to investigate land use and social justice issues. Here is a lesson sequence and some standards. And this in class takes about 3 days. It may take a little longer in a remote environment. But students start out with just using things like Google Earth and just investigating what information that Google Earth can show them. They look at their school, they use the timeline tool, they take some screenshots, they investigate some landmarks. So they make use of this tool that they've probably already seen, but then we're putting it to work and thinking about how we can model how an image gets from a satellite to your computer and labeling those components, and they come back to that. Then they're using something called Forest Watch and looking at deforestation in Cambodia. And they run a timeline tool. They're looking at tree cover loss. And then they're investigating the satellites that are used there, which are the DEMO, SET, and Landsat, and looking at how those satellites are utilized. This would be great for a physics course, also for a Living Earth course in biology to investigate land use and land use change and changes to the surface and the influence of water and the influence of natural resources, all of which are hitting those standards. So I have some talks here. This would be great for students to be working in breakout rooms to watch these and to go over these together. Then the ultimate question is, how can satellites be leveraged to promote a more just world? And using the tools that they're already looking at, choosing a region and investigating how that region has been impacted, and using these publicly available imagery and satellite images and data to investigate that. One of the most powerful assignments I saw from this was students investigating the atrocities in Syria through satellite imagery. And I had these two very white kids who were so moved and disturbed by the imagery they saw, and they learned all about the policy and the human rights issues and the political impacts on this region that affected the geography of this region and the human toll that that took. And these kids moved this science class to tears over the social implications of that science that they discovered. It was really powerful. I've had students that have looked at the Armenian War, they've looked at wars, they've looked at logging, they've looked at areas impacted by climate change, of hurricanes. It's amazing what students can investigate with this assignment. And their final component of that is to make that connection. How can we use these images to make that leverage and promote justice? And this is, I have to say, the most important assignment that I've ever created, because it gets students asking those questions. What is the relevancy of this science to the world and to me? So I have two others that could be used as a precursor to that. Earth observing project, students are choosing an Earth observing mission, and also satellite dynamics. This one would be perfect for a physics in the universe course. The second component here includes designing a Mars mission and including the travel time based on the orbital parameters to get there. Lastly, I included some general astronomy labs, including scientific notation, an easy walk through that. My first attempt at doing a remote design challenge of a pasta tower, which was awesome, by the way. I put them into breakout rooms. And that, again, I emailed parents for weeks saying, your kid just needs to have any type of pasta, any type. And every student did. And I was willing to drop it off at their house if they didn't. And the students loved that. I can't wait to do that again. So here again, I have a bunch of resources for you. Please drop me a line and let me know how these work for you. I am utilizing a lot of this stuff as a component of my PhD. If you would like to be a part of that, if there's any way I can help support you to infuse earth science and astronomy lessons into your coursework, please reach out. I'd love to be able to support you in that. Have a wonderful day, and don't forget to look up.